In this video, we'll take a look at two dice problems which look very similar on the surface, but there is a very subtle and nuanced difference which you will see. And it's good to practice these problems beforehand so that it's easier for you to solve under time pressure when you're facing these questions in the interview. So the first question says, given a fair six-sided die, what's the expected number of rolls required until the first appearance of two consecutive six, that is a sequence of 6 and 6. Now, in all such problems, wherein the success event looks like combination of smaller events, like in this case, we are looking for two consecutive sixes on the dice, which can be broken down into a roll of a six and then followed by another roll of a six. You should immediately think of Markov chains. And if you're familiar with Markov chains, you would probably remember that we write recursive equations and then solve them to find the final answer, as we'll just see in the next few slides. So to solve this, we use the concept of states in Markov chains, tracking the recent history of rolls. So we define the states as states A, B, and C. State A is when no six has been rolled in the previous roll, or we can say that it's a fresh start. State B is when the previous roll was a six, but not two in a consecutive row, not two in a row yet. State C is the sequence 6 6 has just occurred. This is our final absorbing state, terminal state. This is the success event that we are looking to achieve, target sequence. Now let's define EA as the expected number of rolls to reach 6 6 starting from state A. So this is the number that would be our final answer. So we are looking to find the number of rolls required to reach two consecutive 6 rolls starting from state A, which is a fresh start. EB, expected number of rolls to reach 6 6 starting from state B, which is the previous roll was a 6, just one 6. State C has the expected rolls defined as EC. Now, if we have reached EC already, the number of rolls required to reach two consecutive sixes would be 0, because this is the target sequence which has just occurred when we are in state E. So the number of rolls needed would be 0, because we have already reached state C. Now we write the equations. So we are starting from state A. The number of rolls required to reach two consecutive sixes we defined as EA. So let's say we're starting from EA. The number of rolls required would be 1 plus. So one roll would occur, and then we would either go into state B or we would come back into state A depending on what we roll. So if we roll a 6, we would go into state B. So the expected rolls would be EB then. And the probability that we roll a 6 would be 1 by 6. So it becomes 1 by 6 times EB, plus with probably 5 by 6 we roll something else and we stay in state A. So 5 by 6 we stay in state A, and the number of rolls required again is EA. So this becomes our first equation connecting EA and EB. From state B, with probably 1 by 6 we roll another 6 and reach state C. So one roll plus 1 6 times this is EC, which is 0, because this is our absorbing state. And with probably 5 by 6 we roll something else and come back to state A, which essentially breaks our streak, and we have to start over all over again. So 5 by 6 times EA. So this becomes our second equation uh, between A and B. So EB is 1 plus 5 by 6 times EA. So we have two equations and two unknowns. So EA equals 1 plus 1 by 6 times EB plus 5 by 6 times EA. And we have another equation. So from here we subtract 5 by 6 EA from both sides to get EA in terms of EB, just simplifying it. And then we substitute it in the second equation to get EB equals 6 plus 5 by 6 times EB. Solving this, we get EB equals 36 and EA equals 46. So EA is the variable which we had to find. This is equal to 46, which essentially tells us that the expected number of rolls required to get two consecutive sixes is 42. Now let's see a slightly modified problem. Given a fair six-sided die, what's the expected number of rolls until you see a sequence 6 followed by a 5? Now, there's a subtle difference here if you compare it with the previous one. The previous one was 6 and 6, whereas this is 6 and 5. Now, as we write the equations, you will see that the first equation would be the same, but in the second equation, we'll have some difference show up, and that's the important difference between this problem and the previous one. So we will follow the same process. So first we'll define the states. Here we define state A. So no 6 has just appeared, which is this is the starting state. State B, the last roll was a 6, waiting to see if the next roll is a 5. So only the last 6 has appeared. And the state C is the sequence 6, 5 has appeared. That's absorbing terminal state. Now EA is the expected rolls from state A to reach the sequence 6, 5. EB is the expected rolls to reach state B from state B to reach 6, 5. Sorry. EC is 0 since we've already achieved the sequence. Next, we write the equations exactly like the previous problem. So with probability 1 by 6, we roll a 6 and go to state B. So we have the expected rolls from state A is 1 roll plus the number of rolls it would take if we reach state B, which is 1 by 6 times EB, plus with probability 5 by 6, we'll roll a number which is not a 6 and stay in state A. So 5 by 6 times EA. So this is the first equation, and you'll notice that this is the same as the first equation in the previous question. Now from state B, with probability 1 by 6, we'll roll a 5 and reach the state C, which is our absorbing state, and we are done. So the expected rolls from here is 0. So this is this part over here, 1 by 6 times EC, which is 0. With probability 1 by 6, we'll roll a 6 and stay in state B. Since 2 6s in a row could lead to 6, 6, 5 in the future. So this is 1 by 6 times EB. So let's say we roll a 6 and then next again we roll a 6. So we are staying in the same state. Next, with probability 4 by 6, we roll any of 1, 2, 3, and 4, and we'll return to state A, which is our initial state. So this is this part over here. And this gives us the second equation, and you'll notice that this is how the problem is different from the previous question. Now it's very easy. We just have to solve the two equations. So we have two variables, two unknowns, and two equations. So first one gives us EA equals 6 plus EB. And simplifying the second equation gives us EB in terms of EA, simplified to this. Solving them together, we get EB equals 30 and EA equals 36. Thanks for watching. For more questions, visit dataloopr.com, and I'll see you in the next video.